detail. So one little small note on water pressure. Did we go into the formula? We did, didn't we? Rho GH.
No.
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 Yes.
I know we
Yes.
did.
No.
Water pressure P equals rho GH, which is the pressure of water pressure only, or it's not necessarily water pressure, it's any liquid. So we say water pressure, but it's actually any liquid. Equals the density of that liquid times the gravitational constant. Gravitational constant. And multiplied by the depth or the height below the surface. So depth slash height below surface. Okay, so the water pressure or the liquid pressure is the density of that liquid times the gravitational constant for the planet you're on times the depth or height below the surface, which that is. So it's rho GH. Okay, now this applies to any liquid. You could submerge an object below the level of that liquid and it would experience rho GH in terms of outer pressure. That is why you experience pressure when you dive down in a swimming pool. That's why you feel the pressure in your eardrums, because there's that pressure that's to do with how much water. Now or how much fluid. Where it comes from is very simple. If I dive down at the bottom of a swimming pool, then I have all this water above me. All that water above me has a mass. All that water above me has a weight. It's all pushing down on me. So all that weight of water is pushing down on my eardrums. So that pressure comes from the weight of water that's above me. The weight of water has to get pushed down on something. So that pushing down of water is water pressure, is liquid pressure. The weight of the water that's above you is pushing down on you. Therefore, that's why the pressure gets greater. You go in a submarine, you dive down really deep, you've got all the water above you. All that really, it's all got mass, it's all got a weight, it's all pushing down on you, therefore that's what we create liquid pressure. Okay? So, water pressure comes from the density times the gravitational constant times the depth or the height below the surface. Now, what I'll show you is, we're going to just quickly go on to buoyancy, and what I mean by buoyancy. And buoyancy is what keeps things afloat when they're in the water. Okay? How do we keep things afloat when they're in water? Right, and we'll have a look at that. I'm going to show you a little experiment here, and we'll see if it works. And we'll try and get talk about buoyancy.